Yeah. So what is fluid? Basically, fluid is any substance. It can be any substance which can flow, like which can flow from one place to another place, from one point to another point. Such kind of substances can be taken as a fluids. Generally we have three types of matter, right? We have solid matter, liquid matter, and gaseous matter, right? These are the three basic states of matter which you have studied in chemistry. Now when you take solids, Gautam, do they have any natural ability to flow?
No, ma'am. No, ma'am.
Like for suppose I just keep a table, and on the table I'm keeping a block is a solid. Now will it flow on its own?
No, ma'am. No,
No.
ma'am.
So solids are not fluids, they are not taken as the fluids. What about liquids and gases? Suppose let me take the same table, let me pour some water into it, onto it. Okay, so if I pour the water, will it stay at the same place or will it move, will it spread on the table?
It will spread, ma'am.
It will spread on the table. So the liquid spread on the table. Spreading on the table in the sense what, it is flowing from one point on the table to other point on the table, right?
Yes, ma'am.
Now similarly when you take gases, let me take a container. Now let me fill this container with some gas molecules. So do they stay at the same place?
No, ma'am.
No. What do? So inside the container they move from one place to another place. That means they are also moving on their own from one point to another point.
Yes,
So
ma'am.
gases move randomly in the container.
Yes, ma'am.
So if you take the case of liquids and solids, both have the natural ability to move from one place to another place. So such kind of substances are called what? Fluids. So that is the reason we have taken liquids and gases as the examples of fluids. Why not solids? Because solids on their own they cannot move. Somebody has to push the solids, then
Yes,
only
ma'am.
they will move. But when you take liquids and gases, we no need to push, they just flow on their own. Okay.
Yes,
now
ma'am.
now these fluids, better let it be liquids or let it be gases, they do exert some force, they do exert some pressure, and that pressure is called what? Fluid pressure. So what is fluid pressure? It is a pressure exerted by whom? Exerted by fluids.
Yes, ma'am.
Pressure exerted by fluids, it's called fluid pressure. Clear with introduction?
Yes, ma'am.
There are certain basic terminologies that are given in your textbook. Now we'll discuss them one by one.
Yes, ma'am.
Okay. So I think you are clear with the fluid, right?
Yes, ma'am.
So what is a fluid? Anything which can flow from one place to another place or from one point to another point, that is taken as a fluid. And what are the examples of fluids? You can
Liquid.
take liquids and you can take gases. Okay. Now the next terminology is differences between
Differences.
liquids and gases. Liquids and gases. You have any idea about differences? You might have studied in chemistry, no?
Ma'am, liquids molecules are tightly packed as compared to gas.
Okay, so let me take liquids, let me take gases. Let us study on a comparative basis. So let me take first property, that is about packing of molecules. So when I take liquid molecules, how are they packed? They are loosely packed.
Yes, ma'am.
Okay, in the liquids, the molecules will be loosely packed. What about gases? They are very loosely packed.
Yes, ma'am.
Okay, for suppose, let me take a container. Let this be container for gas and let this be container for liquid. Okay. Now, when I take the liquid, how will be the liquid? Liquid molecules will be like this. They will be loosely packed. When you take gases, they are very, very loosely packed. That means what? The space, the gap between one molecule to another molecule is very high in gases. If you see this gap, no, that gap will be very high in the case of gases. That is the meaning of very loosely packed. Okay. Now, when
Yes,
you
ma'am.
take liquid molecules, the gap is a little bit less. Okay.
Yes, ma'am.
Now, let us take second property, that is force of attraction. Can you tell me in which case the force of attraction is high? For liquid molecules or for gaseous molecules?
Liquid.
Yeah. When you see here liquid gas, it's loosely packed. There is less space between them, right? When there is
Yes.
less gap, it means that they have more force of attraction. Okay.
Yes, ma'am.
It just mentioned less force of attraction. But when you take gas molecules, very less force of attraction.
Yes, ma'am.
Okay. Why am I mentioning less for liquids? Because it is very high for solids.
Yes, ma'am.
Okay. Now, next property, gap between the molecules. So when you take gap between liquid molecules, it is more actually. It is more. And when you take gases, the gap between molecules is
Two,
very
ma'am. Very,
very much
very.
high. Okay.
Yes, ma'am.
Very much high. That means comparatively more gap in the case of gas molecules. Okay. Now,
Yes, ma'am.
when you talk of free surfaces, number of free surfaces. So when you take liquid butter, this is the free surface. The top layer, you have taken water in a container. The top surface is called what? Free surface. Okay. So this is called free surface. So when you take liquid, how many free surfaces do we have? We have one free surface. And when you
Yes.
take gas, no better, they don't have any definite shape. No, they don't have any definite shape and they don't sit at one place. So you can't get any free surface here. It has zero free surfaces.
Ma'am, or else you can say infinite.
Not infinite. Infinite means many free surfaces. Gas is not like that, no. Solids have infinite free surfaces.
Okay, ma'am.
Solid has infinite free surfaces. And what about gas? It has zero free surfaces. There is no free surface at all.
Okay, ma'am.
Okay. And when you talk of density, where do I write? Let me write it here. Density. When you
Liquid
take, yeah,
high.
when you take one liquid, throughout the process the density of liquid cannot be changed, because when you take liquids, no better, liquids are incompressible. That means they cannot be compressed. Compressibility means what, Gautam? You have to apply pressure so that volume decreases.
Okay, ma'am.
Decreasing the volume by increasing the pressure, that is called compressibility. So when you take liquid, no, you can't decrease its volume. Though you apply pressure, you cannot decrease its volume. It will be very less decrease. So what do we say? There won't be much change. No change in density. Why? Because liquids are incompressible. When you take gases, no, they have much gap between them, right?
Yes,
So
ma'am.
when you apply pressure on these gas molecules, no, what do they do? All gas molecules, they come closer. So what happens here? Volume decreases. So if volume is decreasing, what happens to density? Density is mass by volume. So if volume is decreasing, density will increase. So you can bring a change in density for the gas.
Yes, ma'am.
Okay. So when we talk of density for liquids, no change. But when you take density of gases, it can be changed. But how can you bring this change? By compressing the gas. When you compress the gas, volume changes and hence density changes.
Yes, ma'am.
Okay. Any doubt in this?
No, no, no.
Okay. Now, next is thrust. So what is thrust? You know about force, right?
Yes, ma'am.
So the perpendicular force exerted by an object on a surface is called thrust. So what is thrust? Basically it's a kind of force. It's a force only. And how it will be? It will be perpendicular to the surface. For suppose imagine a table. On a table we have kept a block. Okay. Enough.
Yes,
So due to gravitational pull, the weight of the block will be acting downwards. W is equals to mg, right?
yes, ma'am.
Now the block is not in free air. It is kept on the table. This is the table. So as the block is on the table, who is holding this weight of the block? It is table only, right?
Yes, ma'am.
So I can say that block is exerting this weight on the table. So this weight is acting on whom? This weight is acting on the table only. Because if there is no table, block will fall down towards the earth. As table is there, table is bearing that weight, isn't it?
Yes, ma'am.
Are you getting my point, Gautam?
Yes, ma'am.
So when you take the solid objects which are in rest position, what we can say is thrust is nothing but the weight of the body, that is m into g.
Yes, ma'am.
Getting my point?
Yes, ma'am.
This is for solid objects, because solid objects, what will be their force? It's nothing but the weight. Weight is also a kind of force, right?
Yes,
But
ma'am.
what is the difference? In the case of force, we take m into a. In the case of weight, we take m into g, acceleration due to gravity. Okay. And what will be the direction of this thrust? It's a perpendicular force. Now if you see this weight, if you see this table is horizontal and the weight is vertical. So what is the angle here? 90 degrees. So force is acting at what direction? Perpendicular direction.
Yes, ma'am.
Okay. And what will be the units of this thrust? As
Newton.
yeah, thrust is a force. So when you take CGS system, it is dynes, and when you take MKS system or SI system, it will be newtons. Okay. And what is the relation? 1 newton is equals to 10 to the power of 5
Done.
dynes. Okay. Is this clear?
Yes, ma'am.
Okay. Now we'll see another concept, that is pressure. Pressure is also called effect of thrust. Thrust means force. Effect of thrust means pressure. Okay. Don't confuse. So
Yes,
what is
ma'am.
this pressure? Just now I told you pressure is nothing but force acting on an unit
Unit.
area. Okay. So for suppose, let me take the same example. This is table and a block is kept on the table whose mass is m. Okay. Now the block is exerting a perpendicular force on the table. What was that? M into g, and this is nothing but our thrust. Okay. So thrust is m into g, because for the solid objects which are in rest position, thrust is nothing but the weight of the body. Okay. Now, so this weight is acting on what better? Is it acting on the entire table or is it acting over this surface?
Over the surface, ma'am.
Okay,
Where it comes.
where, yeah, where there is a point of contact, right?
Yes,
So
ma'am.
the force which is acting on this area, you are considering the force and also considering the area where force is acting. So that becomes the pressure. Thrust is simply a force. When you take thrust, it is simply force. But when you take effect of thrust, we consider where, on which area that force is acting. Whether force is acting on 2 meter square area or 5 meter square area or 10 meter square area, we consider the area also for pressure.
Okay, ma'am.
Okay. So force by area is nothing but what? Pressure. So P is nothing. What kind of force is this? Parallel force or perpendicular force?
Perpendicular.
Perpendicular. So we use the symbol perpendicular like this. Okay. So F perpendicular by area. This is the formula for pressure. Clear with this?
Yes, ma'am.
So from here you have to understand two important relations. Pressure is directly proportional to the perpendicular force. First point. Pressure is inversely proportional to area of contact. Second point. Is this clear?
Yes, ma'am.
For suppose you exert more force, then pressure is also more. You exert
Yes.
less force, then pressure is also less. Okay. For suppose you are exerting same force. Now let us see how pressure changes with the area. What happens if you increase the area? Pressure will decrease, right?
Yes, ma'am.
Uh, you might have seen. Have you ever felt, uh, somebody, by mistake, they keeping their legs on your feet? Did you face that anytime?
Ma'am, can you repeat it?
Like you and your brother might be fighting with each other, right? by,
Yes.
by mistake he's keeping his legs on your feet. Did you face that?
Yes, ma'am.
Okay. So imagine two cases here, Gautam. First case, so this is your leg. Okay, this is your leg. Okay. Imagine that your brother has wore flat chappals, and he's standing on your leg. You feel some pressure, right?
Yes, ma'am.
You feel some weight. Let it be pressure P1. Now let me take the second case. Let me take yourself same leg. Now this time your brother is wearing high heels. High heels. Girls will wear no high heel chappals. Okay. So this time let the pressure acting on you be P2. Can you tell me in which case you feel more pain, more pressure?
Second case, ma'am.
Second case. Why is it so?
Because area of contact is less, ma'am.
Very good. If you see the area of contact that is considered here, area A2 is less and here area A1 is more. So pressure P1 will be less. A2 is less here, so P2 will be more. Clear? So pressure is inversely proportional to the area of contact. Okay. And what is pressure here? Pressure is a scalar quantity. It do not have any direction. We don't consider any direction here. Okay. Clear, Gautam? I'm not getting your voice.
Yes, ma'am. Yes, ma'am.
Clear. Okay. Now we'll see units of pressure. Long back I told you gravitational units of force. Do you remember?
Kg weight by kg weight and gram weight.
Not kg weight, kilogram force weight, gram force weight. Okay.
Yeah,
So
yeah.
when you take pressure, pressure formula is perpendicular force by area. So when we take CGS system, the unit of force is dyne, unit of area is centimeter square. Now when you take MK system, force is Newton and area will be what? Meter square. So this will be the units of what? Pressure. Clear?
Yes, ma'am.
So there was one scientist called Pascal. So he contributed so much to the subject of physics. He proposed Pascal's law, and this Pascal's law was used in modern, car liftings and all, hydraulic missions and all. There was so much application, of his law. So in order to just respect him, what we do is we take this SI unit of pressure as Pascal. Instead of saying Newton per meter square, what do we say is 1 Newton per meter square is nothing but 1 Pascal. So Pascal is actually the name of a scientist, but the same name is considered as a unit of pressure. Okay. So here I can say Newton per meter square or Pascals. This is the unit, SI unit of pressure.
Okay, ma'am. Ma'am, CGS?
CGS, it's the same, dyne per centimeter square. Okay.
Okay, ma'am.
So when you take gravitational units, when you take gravitational units, for force, it is kilogram force. Okay. By meter square. This is in SI system. For force, CGS unit is what? Gram force by centimeter square. This is in CGS system. Kilogram force, gram force is actually the gravitational unit of force.
Yes, ma'am.
Clear?
Yes, ma'am.
Any doubt in this?
No, no.
Now there are certain other units of pressure, like when you take atmospheric pressure, we take it as ATM. ATM is also the unit of pressure. Other units. Okay.
Yes, ma'am.
Now when you take bar, that is also the unit of pressure. When you take tar, that is also the unit of pressure. There are so many other units. Mostly atmosphere, bar, tar, they will be considered for atmospheric pressure. Like we have air surrounding us, right? So
Yes, ma'am.
when you take this air exerting pressure, in such cases we take the units as ATM, bar and tar. Okay. When you
Yes, ma'am.
take liquids, when you take solids, in such cases we consider pascals as the unit. When you
Yes, ma'am.
take pressure due to gases, there we take ATM generally, but it depends, Gautam. You can use any of the unit, but commonly the other units are used for gases pressure. Pascals, these are all used for liquid pressure. Okay. It's not
Okay.
like compulsory they are for gases. You can use any one of them, but generally. Okay. So there are certain conversions which you need to remember. It will be important for your problems. Okay. 1 bar is equals to 10 to the power of 5 pascals. 1 pascal is nothing but 1 Newton per meter square, and 1 millibar. Milli means 10 power minus 3. So it becomes 10 power 2 pascals. Okay.
Okay. Okay, ma'am.
And 1 atm is nothing but 1.01 into 10 to the power of 5 pascals.
Oh,
Okay. and
okay.
where do I write? I write it here. 1 atm is equals to 1.01 bar. These are all the conversion formulas. Okay.
Yes, ma'am.
Any doubt so far?
No doubt, ma'am.
Okay. Now we'll talk about atmospheric pressure. Where are we living? We are living on which planet, Gautam?
Earth.
Yeah. So this is our Earth planet and we are living on the surface of the Earth. Now this surface of the Earth is surrounded by different layers, right?
Yes, ma'am.
Like atmosphere, thermosphere, ionosphere, stratosphere, different layers are there, okay? So this layer which is made up of gases and which is surrounding the Earth. This is actually layer of gases surrounding the Earth. What do we call this layer of gases? We call it as atmosphere, okay?
Yes,
So
ma'am.
atmosphere is basically the layer of gases surrounding the Earth. Now when you take gases, as I told you, fluids includes liquids and gases, right? So
Yes, ma'am.
gases also exert pressure. So but where do they exert pressure? These gases, they exert pressure on the surface of the Earth, okay?
Okay, ma'am.
So this green colored one, this is the surface of the Earth. Okay, so the layer of gases, what do they do better? As gases have random motion, they don't sit at one place, Gautam. They just move from one place to another place because they are fluids. Definition of fluid itself says that they flow from one point to another point. So they don't sit at one place. When they are moving, what happens? They undergo collisions with other gas molecules, and so they come in contact with the Earth's surface. And whenever they come in contact, they exert some pressure. Okay, so this pressure acting on the surface is called what? Atmospheric pressure. So what is atmospheric pressure? This is the pressure given by whom? This is exerted by atmosphere,
Yes, ma'am.
by the gases in atmosphere. Any doubt in this?
No doubt.
Okay, so to measure the atmospheric pressure, there was a chemist called Torricelli and he constructed an instrument that's called barometer. Okay, so we'll just take normal value of atmospheric pressure. The height of the atmosphere will be 800 meters beta, 800 kilometers, sorry. So after this 800 kilometers, we will have some other layers like exosphere, thermosphere, ionosphere, different. You might have studied in social studies, no? Geography part. When you
Yes.
take the height of the atmosphere from the Earth's surface, it is 800 kilometers. Now, when you take the value of atmospheric pressure, ATM pressure means atmospheric pressure, it is 100,000 pascals. If you take in terms of gravitational units, 10,000 kilogram force per meter square. This is the
Okay.
value of atmospheric pressure.
Yes,
So,
ma'am.
so you must get it out, ma'am. 100,000 pascals is a huge force. It's a very high force that is acting on us, right?
Yes, ma'am.
Then why don't we feel that pressure, Gautam? Like we are surrounded by air. Such huge force is acting on us, but why don't we feel it?
Ma'am, it is negligible.
It's negligible in the sense what? Very less pressure. There is no less pressure. Here it's a huge pressure. 100,000 pascals. Negligible means what? Close to zero. It's not zero, right? It is 100,000
Ma'am.
pascals.
Yes, ma'am.
Why don't we feel this huge pressure? Because when you take the human body is made up of what? Blood, water, some liquids are present, right?
Yes, ma'am.
So our body is made up of some liquids, and these liquids balance the atmospheric pressure. Atmospheric pressure is acting on our body, and from inside our body there is pressure acting in opposite direction.
That means the pressure exerted by our body is more than normal.
It's not more. If it is more, we will bulge. It is not more, it is not less. It is exactly equal.
Okay, ma'am.
Imagine, Gautam, inside our body pressure is more. Then what happens? We will bulge.
Okay, ma'am.
Imagine outside atmospheric pressure is more. Then we will be crushed. But we are not crushed. We are not getting bulged. So what could be the reason? Both the pressures are equal in magnitude. It
Yes,
is
ma'am.
equal and they are opposite in direction. Atmospheric huge pressure is acting on our body, but yet our bodies are not crushed. What's the reason? Because inside our body it's made up of certain fluids, and they counterbalance this pressure.
Yes, ma'am.
Got my point?
Yes, ma'am.
Any doubt in this?
No doubt.
Okay, so what is the instrument that we use to measure the atmospheric pressure?
Barometer.
Barometer. Instrument used to measure ATM pressure, that means atmospheric pressure. It's called barometer. And who invented this? It was invented by Torricelli.
Taurus. Yes.
Okay. So there was some certain points that you need to understand related to this barometer. We'll see it. But before that, are you clear with this?
Yes, ma'am.
Okay. So the one which he proposed, no Gautam, it's a simple barometer. That means it's very simple in construction, very simple to use it. We have other kinds of barometers like aneroid barometer, Fortin's barometer. There are so many other kinds, but for you it was given only the simple barometer. Simple barometer. Okay. So it consists of a ball, okay, and it consists of a long tube. Okay. So this ball is actually filled with mercury, and this tube is also filled with mercury. So when you connect these two, what happens beta? Some empty space is created here. That empty space is called Torricelli vacuum. Why it is called vacuum, that empty space? Because that don't have even air. Even air is not present in that. That's why it's called vacuum. And why it was called Torricelli? Because he proposed this, right? He invented this. That's why. Okay, first what you have to do is you have to fill this tube completely with mercury. Till the brim you have to fill with mercury, and you have to take a ball to certain point. You have to fill the mercury, and what you have to do, you have to invert this into this ball. This is a ball of mercury. Mercury symbol is what? Hg,
Yes.
hydrogen. Okay. Now
Hydrogen.
when
Yes.
you invert, what happens? Some of the mercury flows into the ball, and that is why this empty gap is created. Okay.
Yes, ma'am.
Now so how do we measure the pressure is here? So, Torricelli observed certain things. When you take this ball, only this portion of the ball is occupied by the by the tube. If you take the other portions here, those other portions are completely exposed to the air, right? They
Yes.
are very much open to the air. So what happens? Air pressure acts on this surface. Okay. So
Yes, ma'am.
he understood certain things. Let this be air pressure. Okay. And now liquids also will exert some pressure, right? Like if you see on this surface at these portions, who is exerting the pressure? It's nothing but the mercury which is present in the tube, right?
Yes, ma'am.
Mercury is also having weight, so mercury also will exert pressure. So let this be the pressure due to mercury. Okay. So what he understood is, if you take the pressure due to air, if it is more than the pressure due to mercury, what happens, Gautam? Tell me. Like outside pressure is more, then what happens? Then what
It
happens?
crushes, ma'am.
Hmm?
It crushes.
It's not an solid object to crush, no Gautam. It's a liquid. What happens here? Observe the diagram. Here you are applying more push on the sides. So what happens here? The liquid molecules get pushed and they just rise up in the tube. So
Yes,
what
ma'am.
happens is mercury level rises here.
Vacuum will be filled with milk.
Yeah, mercury level rises in the tube. Okay. Now, second thing, for suppose if the air pressure is less than the pressure due to mercury, then what happens? Imagine that mercury is exerting more pressure compared to outside air. Then what happens? Now, this time this will be the direction. From this direction, pressure is more. So, more pressure will be acting on the surface now. So, what happens? This mercury will overflow.
Yes, ma'am.
So, in this case, what
Why
happens?
only we take mercury, ma'am? Why not?
Mhm.
No, why only we take mercury?
Why only we take mercury? Because there are certain advantages. Mercury density is very high. So a small tube is enough to measure the pressure. If you take water or if you take another liquid, they have more more density. I mean, they have they have
Less.
less density. So they occupy more volume. This is a relation between density and volume, right? When you take mercury, density is very high. So how much place it will occupy? Very less space. So very
Yes.
small tube is sufficient.
Okay, ma'am.
Okay, but if you take just 100 centimeters tube is sufficient here. We just take 100 centimeters. Imagine not even 1 meter, just 100 centimeter.
Yes, ma'am.
Okay, but if you take other liquids, no Gautam, they have very less density. So they, then that cases we require very long tube, 1 kilometer. Such kind of long tubes are required. Imagine how much technically it is difficult to handle such long tubes.
Yes, ma'am.
So that's the reason mercury is preferred. Okay, and moreover, mercury is silvery white in color, right?
Yes, ma'am.
Silvery white in color, so it can be easily seen. First benefit is it is having high density, so less volume, so small tube is sufficient, small tube is required. Second advantage is it is silvery white in color, so it can be easily seen. That is the second reason.
Okay, ma'am.
Okay, and third reason, it is having high melting and boiling points and also freezing point. That means it will not freeze easily, it will not melt easily, it will not boil easily. Such benefits are also there compared to other liquids.
Yes, ma'am.
Okay, so what happens in case 2, tell me?
It
Outside,
overflows.
yeah, outside pressure is less, inside mercury pressure is more. In that case, mercury in the bowl, mercury in the bowl overflows. What Torricelli has observed is there was no first case, there was no second case. Mercury level was not rising, mercury from the bowl is not overflowing. So, what could be the reason, Gautam? It is not overflowing, it's not rising also. So, can I say that then the two pressures are equal?
Yes, ma'am. Pressure
The
in air is equal to pressure exerted by milk.
mercury, okay. So, what he did? Are you clear with this? Shall I go for the next page?
Yes, yes, ma'am.
Okay. So, this was the bowl. So, this is the pressure due to air. This is also pressure due to air. Now, this is the height of the mercury from the surface. You have to consider from the free surface the height of the mercury. Okay. When Torricelli has observed this, outside air pressure is equals to inside mercury pressure, then there won't be any rise, then there won't be any overflow. Is this point clear?
Yes, ma'am.
So at this stage, he just noted this height of the mercury column and it was 76 centimeters.
Okay, ma'am.
When he noticed that air pressure was equals to inside mercury pressure at that balanced condition, when he saw the height of the mercury in the tube, how much it was 76 centimeters, and this height is called barometric height.
That means atmospheric pressure of mercury is 76.
It's not like atmospheric pressure of mercury. Atmospheric pressure is because of what? Because of the air. Pressure of mercury is what? Because of the mercury that you have taken inside. Atmospheric pressure is how much? It is 1 atm. When you take
One.
outside pressure, no, in terms of atm, it is 1 atm. Okay.
Okay, ma'am.
And when you take the pressure due to mercury, how much height of the mercury was considered? 76 centimeters. So 1 atm will be 76 centimeters of mercury height.
Yes, ma'am.
When you take outside pressure, one commonly outside pressure is 1 atm, Gautam. Okay, so when you take that 1 atm, that means air pressure, it was balanced by how much height of the mercury? 76 centimeters height of the mercury. So we just take this relation.
Yes, ma'am.
If I take in millimeters, can I say 760 of mercury?
Yes, ma'am.
This is second important relation. Any doubt in this?
No doubt.
Okay. And what do we call this height? 76 centimeters, 760 millimeters. It's called barometric height.
Yes, ma'am.
Okay. And what is this gap called? It is called Torricelli vacuum.
Vacuum.
And what will be the height of this Torricelli vacuum? How much height will be there? The total tube is 100 centimeters height.
24.
Yeah. So this will be 24 centimeters height. Any doubt
Yes.
in this, Gautam?
No, no doubt.
Okay. So, mm, there were certain things that we need to discuss. Note points. So when you take this pressure of the air, it will be equal to the pressure of the mercury when you take 76 centimeters of height of mercury, right, Gautam?
Yes, ma'am.
Okay. For suppose you have measured the barometric height. BH means barometric height.
Okay. Yes, ma'am.
Barometric height. Okay, let us take three different cases. If barometric height is exactly equal to 76 centimeters, the atmospheric pressure of the air will be 1 atm. Okay. For suppose if the barometric height is more than 76,
It will be more than one.
yeah, pressure of the air will be more than 1 atm. If you take barometric height in the tube is less than 76 centimeters, then what will be the atmospheric air? It will be less than 1 atm. More
Yes, ma'am.
than is denoted like this, more than 76 centimeters, less than towards right hand. This is the symbol. Okay. So from these 3 points, can I say that pressure of the air is directly proportional to barometric height?
Yes,
If
ma'am.
height of the mercury increases, pressure outside increases. Height decreases, pressure outside decreases. If
Yes, ma'am.
height is exactly 76, then atmospheric pressure is also exactly 1 atm.
Yes, ma'am.
Okay. And so what I want to tell you is when you take the atmospheric pressure and if you take its relation with respect to simple barometer, it depends on the barometric height of the mercury. And if you take the natural factors that affect the pressure, like as I told you, the height of the atmosphere is 800 kilometers. If it changes when you take summer season, no, the gases will expand due to heat. Gases expand on heating and they contract on cooling. So during summer time, what happens? There will be a slight difference in height of the atmosphere. It will be slightly more than 800 kilometers. So when such kind of changes happen in the height of the air or with respect to seasons, with respect to temperature, what happens? The atmospheric pressure also slightly changes. But we don't consider all of them. We just consider atmospheric pressure is 1 atm. Okay. We take an average basis, it's 1 atm. Clear?
Yes, ma'am.
Okay. And which will not affect, like for suppose, I'll just show you the Google, just wait a minute. Just give me a minute. Okay, so this is your simple barometer, Gautam. So here if you see the tube, can you see the picture here? Yes, Gautam, can you see it here?
Yes, ma'am. Yes, ma'am.
Okay, so here how is the tube? It is completely vertical, right? It is completely erect. That
Yes, ma'am.
that means it is making 90 degrees angle with the surface of the ball.
Yes, ma'am.
So what if you mm, yeah. So what if you tilt like this? Like you are not keeping erect, you are tilting it, you are not keeping 90 degrees angle. Okay, in that case also height will be 76 only. So
Yes,
though
ma'am.
though you tilt it or though you keep it vertical, however you keep the tube, when you take the air pressure 180 m, compulsory how much will be the barometric height? 76 only. Okay, and it
Yes.
also do not depend on the size, Gautam. Mm, just wait a minute. It was not given here. So though you take bulged tube or narrow tube, though you change the thickness also better, it does not vary. It will always have the same height, that is 76. Yeah, here it is. You see this figure, Gautam. You see this figure. First one is normal thickness, second one is little bit higher, third one is completely dipped into the bowl, fourth one is having more area, more diameter, and fifth one is tilted. So however you take the tube and however you keep the tube, what will be the barometric height for 180 m pressure? It will be 76 only.
Yes, ma'am.
ఇక చూడు, మనం లావుగా తీసుకున్నాం, ట్యూబ్ లావుగా తీసుకున్నా కూడా మనకు సంబంధం లేదు. ఎట్లా తీసుకున్నా ప్రెషర్ 180 m ఉన్నప్పుడు మెర్క్యూరీ హైట్ ఎంత ఉంటుందంటే 76 ఉంటుంది.
Yes, ma'am.
ఈజ్ దిస్ పాయింట్ క్లియర్?
Yes, ma'am.
సో థర్డ్ ఇంపార్టెంట్ పాయింట్ ఏంటి అంటే, barometric height do not depend on number one, position of the tube. So however you keep, it doesn't matter. Okay, you are
Yes, ma'am.
keeping vertical or 30 degrees angle, 40 degrees angle, slant position, however you keep, it will be 76 only. And size of the tube and also shape of the tube, size and shape of the tube etla తీసుకున్నా height will be same, 76 centimeters. Any
Yes.
doubt in this?
Ma'am, but the tube which is less than 76 centimeters cannot show 76 centimeters.
No, we have to take a minimum of 100 centimeters tube.
Okay, ma'am.
Okay, no. So any doubt so far, Gautam?
No, no doubt, ma'am.
No doubt. Okay, so you open your laws of motion textbook. We'll just continue that problem. Last 10 minutes I told you, no, I'll discuss the problems.
Yes, ma'am. Ma'am, just 1 minute. Ma'am.
Yeah, take time. Get your book and pencil.
1 minute, ma'am.
Mm-mm.
Yes, ma'am.
Okay, we have completed the questions in first page, right?
Yes, ma'am.
Now we have to start from second page.
1 minute, ma'am. I'm opening.
Mm-mm-mm.
Yes, ma'am.
Okay, just give me a moment. I'm also opening the book. Mm. So it's question number 12, right, Gautam?
Yes, ma'am.
So see that question number 12 and tell me your answer.
Ma'am, once can I read out the question, ma'am?
Yeah. When we kick a stone, that question.
Ma'am, when we kick a stone. Ma'am, that question is now.
Do you open laws of motion only?
Yeah, ma'am. Lost.
It's
Ma'am, that
beginner level objective. 11 questions are completed, no?
that way open. Yes, ma'am. 12th question. It is
12.
not there.
It is not there. What was the 12th question in your book?
Ma'am, how much force is required a body to change its speed from 18 kilometer to 5 meter per second in same direction?
Mm,
Ma'am, that is I think little old book, ma'am. Once can you see the year, ma'am? From starting at the cover it is.
mm, 2021 beta.
Ma'am, yes, ma'am. This is 2022, ma'am. Some difference will be there.
Okay, I'll read out the question. Okay.
Yeah, ma'am.
Later, I'll send you the image of this.
Okay, ma'am.
I'll discuss the question of. Later, I'll send you the PDF of this. Okay. So
Okay,
I'm
okay.
reading out the question. When we kick a stone, we get hurt. Stone వేసి కొట్టినప్పుడు మనకు దెబ్బ తగులుతుంది, అవునా? సో డ్యూ టు
Yes.
విచ్ వన్ ఆఫ్ ద ఫాలోయింగ్ ప్రాపర్టీస్ ఆఫ్ ద స్టోన్ డస్ ఇట్ హ్యాపెన్? ఎందుకు జరుగుతుంది, ఎందుకు దెబ్బ తగులుతుంది మనకు? ఇది స్టోన్ వేసి కొట్టినాం అనుకో, అప్పుడు ఏమవుతుంది, స్టోన్ మూవ్ కాకోకుండా రివర్స్లో మూవ్ కాకుండా ఉండడానికి ట్రై చేస్తుంది. అంటే
In
డ్యూ
a,
టు ఇట్స్ ఇనర్షియా ఆఫ్ రెస్ట్.
yes, ma'am.
Inertia of rest, we feel pain. So ఇది answer is option A. Okay,
Yes, ma'am.
next, a force of 6 newtons acts on a body. Is it the same question, 13th one?
No, ma'am.
Mm. Do you have mobile phone with you, Gautam?
Yes, ma'am.
I'll send the image right to you now. You open it, okay?
Okay, ma'am.
Because if I simply read out, you will not understand. I'll send you the questions now. At least you can see the questions in the phone. Okay. Yeah, you can read the questions from the phone, okay? From the picture that I have sent you.
Yeah, ma'am.
So see the 13th question. A force of 6 newtons. So force is 6 newtons. Acts on a body at rest. So how is the body? Body is in rest position. So can you tell me its initial velocity, Gautam?
0.
Yeah. So initial velocity symbol is what? It is
U.
u. So this is 0 meter per second. And mass 1 kg. So mass m value is given. This is 1 kg. During this time, the body attains a velocity. So before applying the force, its initial velocity was 0. Once you apply the force on the body, you have applied some F force here. So when you apply the force, what happens? The body starts moving, right? So when it starts moving, it will gain some velocity, right?
Yes,
So
ma'am.
what is this velocity? Will it be final velocity?
Yes, ma'am.
Yeah. So final velocity is given. Symbol is V. And this is how much? 30 meter per second. The time for which the force acts on the body. So force is acting on the body, but for how much time? So time t is a question mark here. Did you understand the question? Body is at rest, initial velocity 0. We applied force F, body mass is 1 kg. How much time the force is acting? You have to find out the value of t.
Yes,
Clear,
ma'am.
Gautam? So we have F, we have m, we have velocity. What is the formula for F? It is m into a, right?
Yes, ma'am.
But are we given any acceleration?
No, ma'am.
No. So apply the formula of acceleration now. Keep m as it is. What is acceleration formula? Change in
Minus U.
velocity by time. Final velocity minus initial velocity by time.
Yes, ma'am.
Clear? Any doubt in this step?
No, no, no.
Now substitute in this formula. What will you get? F side, it is 6 newtons. M, it is 1 kg. Final velocity 30. Initial velocity 0 divided by t. Now simplify this. How much will you get? 6 into t is equals to 1 into 30, 30. Now t is equals to how much? 30 by 6. 6 5 is 30. So 5 seconds. So how much time the force is acting on the body? It is for 5 seconds.
Yes, ma'am.
So answer is what now? Answer is option D. Clear?
Yes, ma'am.
Now see the 15th question. 15th question, sorry, 14th question. See the 14th question. A 10 newtons force, so F is 10 newtons, is applied on a body which produce in it an acceleration. So acceleration is given 1 meter per second square. The mass of the body m is. So which formula will you use, Gautam, here?
The answer is 10. No, no, no. 1 minute.
Which
F
formula will
is
you use?
equal
Tell me
to,
the
F is
formula.
equal to, F is equal to.
F is equals to m into a. So F is 10 newtons, m we don't know, a is 1. So what is m now? M is 10 kg.
Yes, ma'am.
Okay, so answer is option A.
Yes, ma'am.
Now see the 15th question. After this question, I'll wind up the class. Okay.
Okay, ma'am.
Now, a ship of mass 3 into 10 power 7 kg Initially at rest. So we have a ship. So what is the mass of the ship? It is 3 into 10 power 7 kg. Okay. Initially at rest, that means initial velocity u is 0 meter per second, is pulled by a force. What is the force acting? 5 into 10 power 4 newtons through a distance of 3 meters. So how much is the distance? 3 meters. Assume that resistance due to water is negligible. That means frictional force is 0. The speed of the ship is, that means you have to find final velocity.
Yes, ma'am.
Okay, so FMUD. So what we have to do now, we have to find the final velocity. How shall we do this? This is question number 15, right?
Yes, ma'am.
So can we find the acceleration? We don't have the time, no. We don't have the time, so we can't find the acceleration. Okay. So we'll do one thing, as I have mentioned in the textbook, we'll use this formula and let us see whether we get or not. Okay. So use this. You have studied equations of motion in
Motion.
kinematics, right? V is equals to u plus at. S is equals to ut plus half at
Yes,
square. V
yes, ma'am.
square minus u square is equals to 2as. You have studied, right? So what do we call them? We call them equations of motion. So from equations of motion, V is equals to u plus at. S is equals to ut plus half at square. S is nothing but d only, Gautam, displacement.
Yes, ma'am. Yes,
And
yes.
v square minus u square is equals to 2s. These are all the formulas that we have. Now which formula shall we use? We have u value, we have s value, and
You don't
we
have
have
a
um, we don't have a value, but f value, m value is given, so we can find a value. F is equals to ma, no? So from these two we can find a value.
yes, ma'am.
Okay, so we can use this formula. You have to use this formula. So first let us find a. A is nothing but f by m. What is f? 5 into 10 power 4. What is
By
m?
3 to 10
3
hours.
into 10 power 7. How much will you get? 10 power 4, 10 power 4 cancel. So 5 by 3 into 10 power minus 3 meter per second square. This is acceleration. Okay. Now substitute in this equation. What will you get? V square. U square means 0 square. 2 into a is 5 by 3 into 10 power minus 3. And what is s here? Distance 3 meters.
3,
So
3,
3
3,
3
3.
cancel. So 2 5s are 10. 10 into 10 power minus 3. How much will you get? 10 power minus 2. This is v square value. That means this is 1 by 100. So what will be v value?
10.
10 or 1 by 10?
Sorry, 1 by 10.
V is 1 by 10. That means 0.1 meter per second. So this is the answer, and point 1 is given in which option? Option C.
Yes, ma'am.
Clear? Any doubt in this, Gautam?
No, no doubt, ma'am.
For finding the acceleration, change in velocity by time, that is one formula, but here f and m values are given, so we use that formula.
Yes, ma'am.
Okay, so remaining questions I'll discuss in the next class, because I have one more class now. Okay.
Okay, ma'am.
Okay, so tomorrow I'll take one more class, Gautam.
Okay.
Tomorrow around 6:40, if it will be either at 6:45 or it will be at 7. Okay.
7. Okay, ma'am.
Either 6, if it is possible 6:45, if not 7. You get ready for 6:45. If I
Okay.
don't take, you can revise that 15 minutes. No, if I do late, at least that 15 minutes you can revise. Okay.
Okay, ma'am.
Bye beta.
Bye, ma'am. Thank you.